Assalamu alaikum students. So in last lecture we complete exercise question 1.9. So let's start with question number 1.10. What is stopwatch and what is least count of mechanical stopwatch you have used in your laboratory? So a stopwatch is used to measure the time interval of an event. We already discussed about the stopwatch and mechanical stopwatch, digital stopwatch in our lecture which is on stopwatch. So you can refer this lecture for further details. So stopwatch is used to measure the time interval of an event. If you want to measure a time interval of any event, then you can use these stopwatches. There are two types of stopwatches: digital stopwatch and mechanical stopwatch. Now question is, what is least count of the stopwatch? So the least count of the stopwatch is 0.1 second. So minimum time interval that a mechanical stopwatch can measure is 0.1 seconds. Now next question is, why do we need to measure extremely small intervals of time? We need to measure extremely small units of time in order to get a measurement more precise, because in nature and also in physics there are many phenomena that may vary with respect to extremely small interval of time. For their experimental measurement we need very precise and precise time measuring instrument. For example, a radar gun tells the vehicle speed must be accurate and measured in a very short interval of time to get the accurate reading. So it means, like if we are measuring the speed of an jet fighter, as we know that it moves very fast, and if we want to know the exact location, we want to measure a very small time we want a measurement in a very small time interval. So there are a lot of other phenomena in which we need to measure extremely small interval of time. This is one of the examples. Now next question is, what is meant by significant figures of a measurement? So we know that all accurately known digit and the first doubtful digit in an expression is called significant figure. It reflects the precision of the measured value of the physical quantity. The detail of, you can see the detail of significant figures in one of our lectures in which we discuss about the significant figures. You can find details in this lecture. In this the answer of this question is, just you write the definition of the significant figures and you just write this important point, that it reflects the precision of the measured value of the physical quantity. How precision is related to the significant figure in a measured quantity? Now this is the explanation of this question. Okay, so there is we have two questions regarding significant figures. So greater the number of significant figures, greater the precision. Each significant figure increases the precision by the factor of 10. Now what does this mean? For example, if we use a standard ruler to measure the length of the stick, we may measure it to be 2.7 centimeter. You could not express it as 2.71 centimeter because your measuring tool was not precise enough to measure the hundredth of a centimeter. So if the same measurement is taken with the vernier caliper, this will be acceptable. So this shows that significant figures is increased, it means precision will also be increased. So this example clearly shows that more the significant figures, more will be the precision. Otherwise you cannot, if your instrument is not precise enough, you cannot get an accurate value. So this is all about the your exercise theoretical questions. Okay, now let's move towards the numerical problems. So the first question, first numerical, express the following quantities using prefixes. We already discussed how we write a number into a prefix form. So if we have 5000, then what we will do, we move a point which is over here, we move a point up to 3 digits, 1, 2, 3. Okay, and why we move 3 digits? Because we have we know the prefix of 10 raised to power 3. We does not know the prefix, so we do not have a prefix of 10 raised to power 4 or 10 raised to power 5. So we move only 3 points to the right side, because our decimal point is on right side and we move on left side. Sorry, we move left side. Okay, so it will be 5 kg as 10 raised to power 3 is 1 kilo. So this is how we can express this 5000 gram into kg as 5 kg. Now we have 2 0 0 0 0 0 0. Now we have this value. Now as we know that the point is over here, the decimal point is over here, we can move a decimal point up to 3 digits or 6 digits. We cannot move between 3 and 6. We can move either 3 digits or 6 digits, because we have a prefix of 10 raised to power 3 or 10 raised to power 6. So if we move this point up to 6 digits, then it will be 2 into 10 raised to power 6, and 10 raised to power 6 is mega. So 10 raised to power 6 is equal to mega. So we can just replace this 10 raised to power 6 with m, which is megawatt. Similarly, you can use these two questions you can solve by yourself. You can see 52 into 10 raised to power minus 10 kg. First of all, you move point before 2, so it will be 2 into 10 raised to power 1 or 10 into 10 raised to power minus 10, and this kg, kilo is 10 raised to power 3. This kg is 10 raised to power 3. Now when you solve this, 10 raised to power 1 into 10 raised to power minus 10 is 10 raised to power minus 9, and this kilo is 10 raised to power 3. When you solve these two, as bases are same, so powers are added, so minus 9 plus 3 will be minus 6. So 5.2 into 10 raised to power minus 6, and we know that 10 raised to power minus 6 is micro, so it will be 5.2 micrograms. Now we have 2.225 into 10 raised to power minus 8. As we know that we only know the prefix of 10 raised to power minus 6 or 10 raised to power minus 9. So what we will do, we move a point over here, so it will be 2.25, and when we move 2.25, we move 2 digits, so it will be 10 raised to power 2. So 2.25 into 10 raised to power 2 into 10 raised to power minus 8. When we solve these two, 10 raised to power 2 and 10 raised to power minus 8, it will be 10 raised to power minus 6, and we know that minus 6 is microgram. So this is how we can write this number into prefix form. Okay, next question is, how do prefixes micro, nano, pico related to each other? As we know that 1 micro equal to 10 raised to power minus 6, nano is 10 raised to power minus 9, and pico is 10 raised to power minus 12. So we can relate nano and micro as 1 nano equal to 10 raised to power minus 9, and this minus 9, you see minus 9 is equal to minus 6 minus 3. We can write like this. So I just write 10 raised to power minus 3 into 10 raised to power minus 6. So As we know that 10 raised to power minus 6 is micro. So it's mean that 1 nano equal to 10 raised to power minus 3 micro. This is one of the relationship. Similarly, 1 pico is 10 raised to power minus 12, and minus 12 can be written as minus 6 minus 6. Remember this, we have only prefixes of 10 raised to power minus 6, 10 raised to power minus 9, 10 raised to power minus 6 and 10 raised to power minus 3. So we convert this 12 into minus 6 and minus 6. So we see 10 raised to power minus 6 into 10 raised to power minus 6. We can replace this 10 raised to power minus 6 with the micro. So it will be 1 pico equal to 10 raised to power minus 6 micro. So we have these two relationships, that 1 nano equal to 10 raised to power minus 3 micro and 1 pico equal to 10 raised to power minus 6 micro. This is how we can relate these two prefixes with each other. Okay, question number 1.3 is, your hair growth rate at 1 millimeter per day, find their growth rate in nanometer per second. So given is growth rate which is 1 millimeter per day, or we can write 1 into 10 raised to power minus 3, because 1 milli is 10 raised to power minus 3 meter per day. You need to find your growth rate in nanometer per second. So you must convert these days into seconds. So how we can convert? As we know that 1 day equal to 24 hours, and each hour is of 60 minutes and each minute is of 60 seconds. So 1 day equal to 24 into 60 into 60. When we multiply these three values, we will get 86,400 seconds. So each day has 86,400 seconds. Now 1 millimeter per day can be now written as 1 into 10 raised to power minus 3 divided by 86400 meter per second. Now to get a nanometer, as we know that nano is 10 raised to power minus 9. To get 10 raised to power minus 9, we multiply numerator with 10 raised to power minus 6. So we must multiply the denominator with the same value. Okay. So what we get, when we multiply these three values, we get 1 into 10 raised to power minus 9, and when we multiply 86400 means 86,400 with 10 raised to power minus 6, we get this value 0.0864. Okay, as this minus 9 is replaced with its prefix which is nano. Okay, so it will be 1 nanometer, and divided by 0.864. When we divide 1 with 0.0864, we get 11.54, and now it is in nanometer per second. So the growth rate in nanometer per second will be 11.54 nanometer per second. Now question number 1.4 is, rewrite the following in standard form. Standard form means you need to write in, of course these are given in the scientific notation but not in standard form. To make it in standard form, we know from the definition of the scientific notation that the number multiply with the power of 10 must be between 1 and 10. So it's mean that if this number is not in between 1 and 10, then it is not in standard form. To make it in standard form, this number must be between 1 and 10. So you see in this example A, it is 1168. To become it this number between 1 and 10, we move this decimal point which is before, after 8 we move with first non-zero which is 1. When we move our point like you can see in this example over here, it will be 1.168. Now how many points we move? 1, 2, 3. So it will be 10 raised to power 3 into 10 raised to power minus 27. Now as bases are same, so powers are added, so 3 minus 27 is minus 24. Okay, so it will be 1.168 into 10 raised to power minus 24. Now next question is 725 into 10 raised to power minus 5. So first of all you must convert this number between 1 and 10. How you can convert? Move a point after 7. So how many points you move? 2 points. So we write this number as 7.25 into 10 raised to power 2 and 10 raised to power minus 5 into 10 raised to power 3. Remember this 3 is from kg. Okay, we convert this number, this kg into its form, its value, we give its value. So it will be 7.25, as bases are same, so 2 minus 5 plus 3 is 0, or it will be 7.25 grams. So this is how we can convert a number into its standard form. Similarly 32 into 10 raised to power 5. Now this 32 is not between 1 and 10. If we move a point after 3, it will be 3.2. Now when we move a point from here to here, it will be 3.2, and we just move one digit only, so it will be only 10 raised to power 1. And when we solve these two, it will be 10 raised to power 6, so it will be 3.2 into 10 raised to power 6. Now last part of this question is 0.02 into 10 raised to power minus 8. 0.02. So we move this point after 2, so that this number is between 1 and 10. So when we move this point after 2, it will become 2 into 10 raised to power. How many points we move? 1, 2, and we move this point from left side to the right side, so it will be minus 2. Okay, it will be minus 2. Like here you can see, okay, there is a mistake over here, we can just write 2. Okay, now it will be 2. Now when we solve 10 raised to power minus 2 into 10 raised to power minus 8, minus 2 minus 8 will be minus 10. So standard form of 0.02 into 10 raised to power minus 8 is 2 into 10 raised to power minus 10. Okay, and remember this thing, the check for the standard form is that your number, this number which is multiplied with power of 10 must be between 1 and 10. So now you see all these numbers are between 1 and 10, so this is the standard form. Now write the following in the standard quantities. You can do by yourself. This is important question, that seconds in a day. So we can write, as we know that one day is 24 hours, 1 hour is 60 minutes, 1 minute equal to 60 seconds. So each day has 24 into 60 into 60 will give you to 86,400 seconds, and now we can convert this 86,400 seconds into scientific notation or a standard form by moving its point after 8, and it will become 8.64. 8.64, and how many points we move? 1, 2, 3 and 4. So 10 raised to power 4. So the standard form of a second in a day is 8.64 into 10 raised to power 4. Now next question is, on closing the jaws of the vernier caliper, the zero of the vernier is on the right side. Now it is on the right side, it means that error is positive, such that fourth division of the vernier scale coincide with the one of the main division. Find the zero error and the zero correction. So in this main scale reading is 0, and vernier scale reading vernier division coinciding with the main scale. It's the fourth division. You see that fourth division of the vernier scale coincided with one of the main scale division. So the vernier scale division coinciding with main scale is the fourth division. So as main scale reading is 0, but vernier scale reading, how we can find vernier scale reading? By multiplying this fourth division with the least count of the vernier caliber, and we know that least count of the vernier caliber is 0.01 centimeter. When we multiply this least count with this division, we get 0.04 centimeter, which is vernier scale division. Now zero error is main scale reading and vernier scale reading, so it will be 0 plus 0.04 centimeter. The answer will be 0.04 centimeter. This is called zero error. Okay. Now, as we know that 0 is on the right side of the main scale, it means that zero error is positive, and we know that when zero error is positive, then its correction is negative. Okay, so remember this point. When zero error is positive, then its correction will be negative, so zero correction will be minus 0.04 centimeter. Now next is question is, a screw gauge of has 50 divisions. So total divisions on its circular scale is 50. The pitch of the screw gauge is 0.5 millimeter. What is its least count? So given data is, division on the circular scale of the screw gauge are 50 divisions and the pitch of the screw gauge is 0.5 millimeter. As we know the formula, the least count can be found by dividing pitch of the screw gauge with number of divisions on the circular scale, and pitch of the screw gauge is 0.5 millimeter as given in the data, and number of division on circular scale is 50. So just divide 0.5 with the 50. The answer will be 0.1 millimeter or 0.01 centimeter. It is not 0.1. It is just correct this value, 0.01 millimeter. So answer will be 0.01 millimeter. Now next question is, which of the following quantities have three significant figures? So we know the rules of the significant figures. So if we count the significant figure, as we know that the zeros between the significant numbers are also significant, so it has 5 significant figures. Now it has 3 significant figures. Why? Because these zeros are used for the spacing, so these are not significant. Similarly, this expression is also has 3 significant figures, because the number of digits multiply with this number power of 10. These are the significant figures. So this value has 3 significant figures, because zeros between the significant figures are also 0. And similarly 3.010 seconds, the significant figures in this quantity are 4, because zeros after that decimal are also significant, are used for the spacing. Okay, right, just cut this thing. Okay. So we come to know that this option B and option C has 3 significant figures. Now what are the significant figures in the following measurement? And same rules you can apply the rules for finding the significant figures. We come to know that at 1.009, as these two zeros are between the two significant numbers, so there are 4 significant figures. Similarly, it has 3 significant figures, because these zeros are used for spacing. They are not significant, but 4, 5 and 0 are the significant. Similarly, this quantity also has 3 significant figures, and this quantity has 4 significant figures, because zeros between the significant figures are also 0. So now our last question of this exercise is, our chocolate wafer is 6.7 centimeter long and 5.4 centimeter wide. Calculate area up to reasonable number of significant figures. Now, first of all, we write a data. We have length of chocolate wafer and width of chocolate wafer, and area can be found length multiplied by width. Now simply just multiply 6.7 with the 5.4, we get 36.18 centimeter square. Now given data has two significant figures. You can see the length of chocolate wafer has two significant figures and width also has two significant figures. So answer must be in two significant figures, not four significant figures. So we just skip these two numbers and the answer is 36, because we need to find the area up to reasonable number of significant figures. So length and width have two significant figures, so area must also have two significant figures. So this is all about today's lecture. We complete this chapter, and you must revise all these lectures so that you can understand all these questions. So thank you very much, students.